Hello and welcome to Guessing the Methods exam. This is part 1. Now last year I guessed the methods exam, but this year this exam is written by my past students. You know they're clever because I taught them. They started their own company. This is it here. You can check it out at the link in the description below, and they've got all sorts of stuff. Check the newsletter out. It's awesome. Alright, let's get started. Question 1. Pause the video, try it out. I'm going to do it. So the nice thing about having someone else write the exam for me is that there's questions in here that I've never considered before. This is definitely one of them. Alright, determine the domain of the function, so all the possible x values of that function. Now I have no idea what that function looks like, but I think I can simplify it. So f of x equals ln e to the x. So if I've got a power of a logarithm, that power can come out the front, x ln e. Now you should know that ln e, the value of ln e, so like that's log base e, that's 1, right? So x times 1. So in other words, what we're looking at is the equation f of x equals x. You might have seen this in grade 9 as y equals x. So what does y equals x look like? It's a straight line, 45-degree angle, straight up like this. Now, what is the domain of that? Well, it can be all of the x values positive, all of the x values negative. It can be 0. It can be any of these things. Therefore, the domain is all of the real numbers, D. All right, let's celebrate. And next question. All right, so pause the video, try the question yourself, and then I'm going to get stuck into it. Alright, so what have we got here? We've got some sort of confidence interval for a sample proportion. I can see of 35 Queensland students surveyed. Alright, so good idea to write down some facts here. I've got n equals 35. Alright, so I've got 40% are planning to go overseas during summer break. So P is my 0.4. And which of the following shows the correct expression for a 95% confidence interval? All right, and I should have a number in my head for 95% confidence intervals, and that's 1.96. All right, so putting all of this together, my confidence interval is going to be whatever my p-value is, which is 0.4 minus 1.96, my z value for 95% confidence, square root, and then probability of success, 0.4, probability of failure, 0.6. So they're multiplied by each other over the number that was in our thing, the number, 35. All right, so that's the lower confidence interval. Do I need to do the upper confidence interval? Not really, because it's just that with a plus, right? So which of these options looks exactly like my option here? Nothing looks exactly like mine, but it's only because I've reversed the order in which I've done those. It doesn't matter though, because multiplication goes both ways. I can see my answer is option D. Done. Okay, celebrate. Next question. Let's get into it. All right, so here's a question. Have a try of it. Pause the video. All right, I'm going to do it. Select the correct equation for the function this when it is reflected across the line y equals x. All right, so if you're not sure of what to do here, a very good idea is to draw a picture. So that's what I'm going to do. I have a function like that. I don't care exactly what it looks like, but that's the rough idea. And it's going to get reflected across this line. So it's going to end up looking something like that. Okay, basic idea, that's what we're doing. Now, this question, when I first read it, I was like, oh, this doesn't even feel like it's in the method syllabus. This feels a little unfair. So then I jumped into the method syllabus and I found this. Recognize and use the inverse relationship between y equals e to the x and y equals ln x. So that's what this question is really asking us to do. Recognize and then use this inverse relationship. So get rid of this picture and let's go. So the original function that we've got here is y equals e to the x minus 3 plus 2 on the end. Okay, and now we rearrange this to make x the subject. So that's going to be y minus 2, sorry about the squeak. Now the key here now is to use this inverse relationship of these functions, right? So we can rewrite this function as ln, so log base e, bracket, whatever this part is, y minus 2, equals x minus 3. Now this move might not feel overly intuitive to you, but just remember a equals e to the b can be rewritten in the logarithmic form as ln a equals b. And that's all I've done here, right? But a isn't a is y minus 2, and b isn't b is this x minus 3 here. All right, I can just do one more step here, and I can say that x equals ln y minus 2 plus 3. Okay, what have I done? I haven't really done anything, right? All I've done is take something that was written in this form and rearrange, and do this. If I type this into graphing software, I'll get like this exponential function. If I type this into graphing software, I'll also get an exponential function, right? In order to find the inverse, in order to reflect it across that line y equals x, we swap x and y. All right, so by swapping x and y, we now get ln x minus 2 plus 3 equals y. Or to read it a different way, y equals ln x minus 2 plus 3. Or to use function notation, f of x equals ln x minus 2 plus 3. That means that our answer is A. Done. Next question. Now I just went and opened a new set of pens for these, so no more squeaking. Let's go. All right, pause the video, try it yourself, and then I'm going to do it. All right, so part A says, in a school week of 5 days, determine the probability that Josie's mum drives her to school at least once. All right, you should have read through this and you should have thought, oh wait, there's 5 days, there's a probability of success. We're talking about binomial probability. Now this question is tech-free, no calculator allowed, so we're going to have to use this thing here. And that means that part A feels tricky because it's saying drives her to school at least once. So the probability, oh, that pen was on hard. Okay, the probability that x is greater than or equal to 1. Now that feels like a problem because our formula doesn't deal with greater thans or equal tos, it only deals with equal tos. But trick, and this comes up all the time in these externals, if you're asked to find greater than or equal to 1, or greater than 0, we can say that that's equal to 1 minus the probability that x is equal to 0. And that our formula can deal with. All right, putting in some stuff here, we have 1 minus, and then I'm going to use my formula, NR, 5 trials, 0 successes. Now the probability of success, actually I don't have to use the letter P because I know the probability of success. The probability of success is 0.9. Now how many successes do we want? 0 successes, right? And then we're going to multiply that by the probability of failure, 0.1, 0.9, 0.1. How many failures do we want? We want 5 failures, right? All right, now tech-free, these questions can feel tricky. 1 minus 5, 0. Now, anytime you've got a combinations thing here, and you've got a 0 here, there's only one way to have 0 successes from 5 trials. So that's a 1. Now, anything to the power of 0 is 1. And then this, that feels tricky. 0.1 to the power of 5. That's going to be easier if I deal with it as a fraction. 1 over 10. 1 over 10 is the same as 0.1 to the power of 5. All right, simplifying this, 1 minus, And then we have 1 times 1 times that. So it's just going to be this, whatever this is. Now 1 to the 5 is just 1. And 10 to the 5 is 10 with 4 zeros after it. And I can write it a little bit like that. 1 minus 1 over 100,000. So that's going to be equal to 99,999 over 100,000. Hopefully you can see what's happening there. You can write this as 100,000 over 100,000, subtract 1 from it, and you'll get this. I have answered part A. I suppose we better celebrate that. And let's do part B. Okay, determine the expected number of days Josie is driven to school. All right, so expected number of days, the mean from a binomial probability. I think we do have something on our formula sheet for that. There it is. Okay, so the mean is equal to NP. So that's going to be super straightforward. The mean is our expected number from a number of trials. So the expected number, or the mean, is equal to the number of trials. So there are 40 days. Okay, so 40 times the probability of success. And now I'm not going to use that 0.9. I'm going to use 9 over 10. Just because it's easier to do that multiplication than deal with decimals. I think that's a good moral here. If you see decimals, why not use fractions? Okay, so 40 times 9. Actually, let's just get rid of these zeros here. That's better. 4 times 9 is 36. 36. All right, so there's my answer for part B. Way easier than part A. Let's celebrate though anyway. And we may as well do part C right now. Determine the standard deviation for the number of days Josie is driven to school in the term. All right, so the standard deviation, we have our formula up there as well. It's going to be equal to, actually, we've got a variance formula up there. So the variance is equal to NP1 minus P. That's the variance, but I want the standard deviation. So I'm going to need a square root in there as well. Okay, the square root of n times p. Now, actually, I already did n times p. I got 36. Times 1 minus p. Now, p is 9 over 10, so 1 minus p is 1 over 10. That's going to give me the square root of 3.6. I think we can stop there. I don't think we're going to come up with a nice value for the square root of 3.6. Now, there are other answers that a person could give here. So they might an alternative answer might be something like the square root. Now, 3.6 is the same as like 36 over 10. And that's equal to the square root of 36 over the square root of 10. The square root of 36 is 6. Can't really do much with that. So end up with 6 over root 10. That would also be an acceptable answer. I think these are both good. Someone who knows all about rationalized denominators might go a step further, multiply top and bottom by root 10 and get a different answer. But I think these are good. We're tech free. Let's celebrate. And one last question for this video. All right, tech free. Check it out, read it, attempt it yourself. It's a tricky one. All right, I'm going to do it. A water tank is being filled from a stream while also being used by local residents. So that means water's going in, water's going out. Okay. The rate at which the amount of water in the tank is changing is given by the following function. So the change in litres with respect to time is equal to 60t minus 180, where L is the number of litres at time t days. If the minimum number of litres in the tank is 200, determine at what times the tank will contain 320 litres. Big question, big ideas. Okay, what have we got? We've got a derivative here. Okay, so I guess if I integrated that, I would have an equation that would show me how many litres there are given an amount of time. So why don't I do that? So I can say that L litres is equal to whatever the integral of that is. So that's 60t squared over 2 minus 180 t plus c. Okay. Now I need some information, like I need to know something about this thing in order to find this c value. Tank's being filled, da 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 da. The minimum number of litres in the tank is 200. The minimum number of litres in the tank is 200. So this is at a minimum when the derivative of this is equal to 0. All right, think about that. So I've already got the derivative of that. It's up there. So maybe I shouldn't have done this after all. Maybe I should have just let this equal 0. Because when this is equal to 0, the number of litres in the tank is 200. All right, let's try that. Let dl dt equal 0, right? Because at that time, we know the minimum number of litres in the tank is 200. Let's do it. 0 equals 60t minus 180. Oh, if I solve that, what am I going to have? I'm going to have time. That's interesting. All right, 180 over 60 equals t. T equals 3. All right, let's stop and interpret. At time 3, at t equals 3, it's at a minimum, but also we know the number of litres in the tank is 200. The minimum number of litres in the tank is 200. All right, so litres equals 200. All right, that's good news because now that I've done this little bit of extra work and I know that at time 3, litres equals 200, I can sub it into this equation. All right, so let's sub 200 for L and let's sub 3 in for T, like that. All right, numbers are a little bit big for tech free, but I don't think we can't handle it. 60 divided by 2 is 30. 30 times 3 squared, 30 times 9 is 270. 180 times 3, that looks like it's going to be about 540 minus 540 plus C. Okay, so figuring out what our C value is, we just move everything over to one side. C equals 200 plus 540 minus 270. Bit of a mess there. All right, C is equal to 740 minus 270. All right, something like 470. All right, it's pretty much over now. We've just got one more little step to go. Determine at what times the tank will contain 320 litres. Now, a hint here, if you ever see this little like S in brackets, it probably means that there's more than one answer. Not always, but probably. Okay, so at what times will the tank contain 320 litres? So let's put 320 into our complete equation for litres. So our complete equation for litres, I don't know why I'm holding that 60 over 2. It's really just 30t squared minus 180t, and then that C is 470. All right, and then we need to solve that. Wow, okay. What I'm seeing is that every one of these has a 0 on the end, so I can probably just divide everything by 10. So we know that 32 equals 3t squared minus 18t plus 47. So that makes things a little easier. It's a quadratic, so I really need it to be 0 equals something. 3t squared minus 18t. And 47 minus 32 is 15. Okay, I can divide everything by 3. So 0 equals t squared minus 6t plus 5. That is a pretty straightforward quadratic now, so I should just be able to factorize it. I think like probably a 5 and a 1, like a -5 and a -1. If I expand that, I'm sure I'm going to end up back where I started. Therefore, using our null factor law, t minus 5 equals 0, so t equals 5, or t minus 1, t equals 1. 2 answers, t equals 5, t equals 1. So I've said it before once in this video, I really like that my friends are writing this paper for me and I'm not writing it, because there's questions in here that I haven't really considered too much. And this first step here, where you've got to think a little bit about the information you've been given, is good. The advice that I'm going to give you here is make a first step. I didn't know how to solve this question when I first started doing it, but once I'd made my first step, I could move forward. And then another step, and then another step, and before you know it, we're here, and we're celebrating, and we're done. All right, that's it for today. We went 100% tech-free. We did 3 multiple choice questions, 2 short response questions. Thank you very much to these people right here. Go and check out the website. You'll get all sorts of cool stuff there. I will see you in part 2.